Hello friends, welcome back to the class of thermodynamics. In today's session, we will see about the new term entropy. What is entropy? Okay, so for defining entropy, we will go through this figure. Now here it is written, two reversible adiabatics cannot intersect each other. Now see this PV diagram, how it is represented. Process AB is there, this is isothermal process. Process BC is there, which is adiabatic, and process CA is also adiabatic. And it is saying that this is not possible. Two adiabatics cannot intersect each other. Why? If it will happen, then it will violate your second law of thermodynamics. There should be some amount of heat rejection. If you remember Carnot cycle, I told there is you added in one isothermal process, in other isothermal process there is heat rejection. Now here there is no heat rejection. Why? Because another isothermal process is missing. And adiabatic process there is no heat transfer, so there will be Q0. So there is only one heat added, there is no heat transfer. This is not possible. So two reversible adiabatic cannot intersect. There should be one isothermal followed by adiabatic, then again isothermal, then again adiabatic. This should be the thing. Correct? Now, based on this comes the Clausius Theorem. I will tell you about the entropy afterwards. First, we will see Clausius Theorem based on this concept. Now, this is PV diagram. This is one body. You have divided this body into a small number of small strips. Okay? Now, these strips constitute small or separate cycles. You can say Carnot cycle. Means there are four processes in each cycle. Let this A take A, B, C, D. First concentrate on this A, B, C, D. What is happening? A to B is isothermal process. Heat is added. dQ1 amount of heat is added. Now T1 is B to C. B to C is adiabatic process. Next C to D, again heat reaction is there. dQ2. dQ2 amount of heat is rejected. Again D2A, it is reversible adiabatic. So this is the four processes. Like this, for each cycle, these small strips, we have formed different cycles. ABCD is one, EFGH is another, like this, so on. For first ABCD, heat added is dQ1, heat rejected is dQ2. In second EFGH, heat added is dQ3, rejected is dQ4, and so on. Correct? So what we have done? We have taken a one body, we have divided into small strips. Means we have converted into number of small cycles. D represents small delta, very small change. Okay. Now we will see from temperature scale. What is the temperature scale? Relationship between temperature and heat transfer. So dq by T1 equals to dq by T2. dq by T1 is equals to dq by T2. This comes from the concept of temperature scale. Okay. Now, because dq is what? If you go back side, dq is heat rejected. Heat rejected is represented in negative sign. Okay. This we have already seen first law of thermodynamics. Heat rejected is represented by negative sign. So here, what will happen? Put here negative sign. Put here negative sign. Now when you will put here negative sign, bring this on the left hand side. You will get dq1 by T1 plus dq by T2 equals to 0. Correct? Right? Now, in same way, you have to take the second cycle and you have to write expression dq3 by T3 plus dq4 by T4 equals to 0 and so on. Like this, it will go on like this only. So what you can say, when you will add, you will get dq1 by T1 plus dq2 by T2 plus dq3 by T3 plus dq4 by T4 and so on. This total sum is equals to 0. So you can say summation of dq by t is equal to 0, or integration of dq by t is equal to 0. Anything, either summation or integration of dq by t is 0, you can say. Correct? Something is here. This is for reversible process. This is important conclusion you have got from the Clausius theorem. For reversible process dq by t, cyclic integral of dq by t is 0. But if it is not reversible process, then it will be less than 0. It will be less than 0. For reversible process, this dq by t is 0. For irreversible process, it will be less than 0. Less than sign will come here. Here it will come like this for irreversible process. Note on this thing. Okay. Now, based on this, we will see entropy. We will define entropy as a property. How? See this graph, PV graph. Two states are there, I and F. I represents initial, F represents final. So from I to F to the process R1, or path to the path R1, it is coming from I to F. Again from F to I, it is going through path R2. So there are two paths or two processes. One from I to F to R1, next from F to I to R2. So complete cycle it is covering to the two paths or two processes. So from the Clausius theorem, what you can write? dq by t is equal to 0. Okay, correct? Now dq by t for R1 from I to F. Okay, next for R2, F to I. Correct? See, in cyclic integration of dq by t. For first R1 starting from I ending to F, correct? From I to F. Next for R2 starting from F ending at I. So F to I. Now bring this thing on the right hand side. So it will be minus. It will be minus. Okay. Now if you have to make it positive, if you have to make it positive, what you can do? You can reverse this limits. You can reverse these limits, then it will become positive. Means in place of F put I, in place of I put F. Okay? See, R1 will be same as it is I to F dq by t, but here now it is reversed to make it positive I to F. So what is happening? R1 is also from I to F, R2 is also from I to F. So whatever path you are following or whatever process you are following, what is happening? It is same. Integration of dq by t from I to F is same in the case of R1 as well as in the case of R2. Okay? So this is the important thing. Means it is not depending on the path. It is depending only on the states, initial and final states. You can see here. So what does it mean? If it is not depending on path, it is not a path function. It is point function depending on the points or the state. So it is a property. Correct? So integration of dq by t is nothing but a property. Now which kind of property? So here it is defined as, this property is given the name as entropy. This property is given as name as entropy, change in entropy. Change in entropy is SF minus SI. This is equals to cyclic integral of dq by t from initial to final state. This is the important conclusion. And this is your property. From here the property entropy came into existence. Okay, so if you were asked to prove, you will prove like this only, starting from temperature scale, Clausius theorem, you will proceed and you will come up to here. Okay, so note down this thing. For reversible process dq by t is equals to delta s. For reversible process dq by t is equals to delta s. Note down this is the important conclusion. Thank you for the session of entropy. I hope you have understand what is entropy. Entropy is property. We have proved the entropy as a property. How? From the Clausius Theorem with the help of temperature scale. Okay. So entropy is also property, means it is a point function, depends on the state. It doesn't depend on the path. Okay. So I hope this session was also useful. We will meet you in the next session of thermodynamics. Till then, take care. Goodbye.